Okay, so graphing nonlinear functions, section 8.2, starting with what is a function notation. So function notation is just the symbol f of x, which means the function of x. Okay, so the function of x. So it's basically telling us that it is a function, meaning it passes the vertical line test. If you remember back from algebra 1, if I were to draw a vertical line anywhere on this graph, if it only crosses once, okay, then that is going to be a function. So they're telling us it's a function by putting it in this notation. And then the function of x just means that x here is going to be my independent variable, okay? So that's what you're used to seeing. We usually look at it as something like y equals 3x plus 2, okay, where we have our y value and we have our x value. Now the only difference is function notation. Instead of having y equals, we have f of x equals. So 3x plus 2. These two things are the same thing, okay? They're both in respect to x. This is my independent variable, okay, and they're both would have a slope of 3 and a y-intercept of 2. The only difference is the y and the f of x. It's just a different way to write them, but they are the same thing. Okay, so when they give me something like this, it says y or f of x. So essentially f of x is this whole function. This entire graph would be my f of x. When they say f of 4, what they mean is that x here is 4. Okay, so in this graph, when x is 4, what is my y value? So I come over here to x is 4, I go up until I hit the graph, and that point there is going to be my y value. So f of 4 is equal to 2. Okay, so when x is 4, y is 2. That's all this thing is asking for. So here it says, what is f of negative 2? Okay, so what they are asking is when x is negative 2, what is y? That's what they're looking for. So when x is negative 2, the function is equal to 1. So f of negative 2 is equal to 1, not negative 1, sorry. F of negative 2 is equal to a positive 1. So that would be your answer there. F of negative 2 is positive 1. Now here it's a little bit different. It says find all x values, all being key, such that f of x is equal to 1. So now they want to know, here, where is my function equal to 1? Okay, this is where is x. When x is 4, what is the function equal to? Here, this is when my function is 1, what is my x? So essentially they're asking when y is 1, okay, x is equal to what? So you're going to come up here to where y is equal to 1, okay, and follow it across and find all x values. Okay, so it's not just this positive 2 is going to be 1, x is equal to 2. So when x is 2, y is 1, that's true. Okay, but I also have when x is negative 2, y is also 1 there. So there's two answers here. Okay, so when y is 1, I've got two spots. I just follow it across at 1 and find all the spots where it hits the graph. So negative 2 and positive 2. So that would be my two answers. Okay, so I would suggest that you click off here, pause this, try this one on your own, and then come back and see if you can get the same answer that I have. Okay, so moving on for us, g of 5. So that means when x is 5, so come over here to where x is 5. 1, 2, 3, 4, 5. Here's x is 5. Follow that up until I hit the graph. Okay, when I hit the graph, it's right there at y is equal to 3. So g of 5 equals 3. Do the same thing here. So g of 0, so this is saying when x is 0. Okay, so right here is where x is 0, is along this axis. Okay, so when x is 0, okay, well here it is hitting the graph. This is where x is 0. What's my y value here? Y value on this line is 0. So when x is 0, y is also 0. Now it's a little different. Find all x values, such that g of x is equal to 0. So now I'm looking for when y is 0, what is x? Okay, y is 0 happens here at this axis. This is where my y is 0. Haven't gone up, haven't gone down. This is y is 0. So follow it across. Okay, I've got x is negative 4. So if I did negative 4, y would be 0. Okay, when x is 0, y is also 0. And then when x is 3, y is 0. So So you've got 3 answers on this one. -4, 0, and 3. All of those give me a y value that is 0. Okay, and that's really it for those. That's how you pull the information off the graph using function notation. Now this next part, they say write the following as ordered pairs. I believe in your homework and your tests and things like that, they would say something like write the corresponding ordered pairs. Okay, corresponding ordered pairs just means write the ordered pair that goes along with this particular notation. So f of -2 equals to 5. Okay, so an ordered pair we need to write in XY format. Okay, it's just a plot on a point on a graph, right? And then here we already said this is the x value, this is my y value. Okay, x is in the parentheses, the whole thing is equal to the y value, so that is my coordinate pair, -2, +5. Okay, and it's as simple as that. So here my x is 0, my y is -7. Okay, go ahead and hit pause, try the your turn, come back, make sure you got the correct answer. Okay, we're going to continue on with this one. So here when x is 3, y is -1, and when x is 50, y is 0. Order does matter. You have to go x and then y. You can't flop them, okay? So make sure you put them in the correct order. Now on this next part, okay, the instructions here are going to say something along the lines of graph using ordered pairs. Okay, we didn't write this in the actual notes, but this is what this means, graph using ordered pairs. Now when you do this, you have to actually create a t-chart, especially when we go to do this on the test. You have to make a t-chart. Okay, you have to show your work for this, so please keep that in mind. Do not just draw random things, okay, or just draw the shape. You're going to have to actually find the t-chart, find all your x, y values, all your ordered pairs, okay? So that's this right here. Begin by finding the ordered pairs. You can only graph by ordered pairs if we have ordered pairs, right? So we're going to do that by making a t-chart. So you have your x and your y. Now when I choose, I'm going to choose x values. They don't give me any, okay? They just want me to graph this by finding ordered pairs. So I have to figure out my ordered pairs, which means I need to actually choose numbers and plug them in for x. So for instance, I'm going to choose -2, -1, 0, 1, and 2. Now you don't have to choose these numbers. You don't have to make them in order. Okay? You do want to make sure that you have both negative and positive numbers, because if you don't, you're not going to see the full picture. You want to see the full picture, and this is where knowing your parent functions comes in handy. This right here is an x squared. So I know it is a quadratic, and I know that it should have a U shape. Okay? I know that by knowing my parent functions, which means when I go to graph these, I need to make sure I see that U shape. It needs to actually turn. Okay? Because if I don't show enough points to show the turn, then I'm going to lose points. So make sure that you choose enough points and the right points so that you actually see that U shape emerge. So for instance here, starting with x, we get x is -2. We're going to plug that into our function. Okay, so when x is -2, plug it in. Okay, it's a substitution. You've done substitution before. You just substitute that -2 in for x. Make sure you use parentheses. If you don't use your parentheses in the calculator, it's not going to give you the correct answer. It's going to say it's -4, when it should be -2 times -2 makes +4, because a negative times a negative makes a positive. Okay, so when x is -2, y is +4. Go through and do this for each one. So -1 squared is going to be +1. F of 0 is going to be 0 squared, which is 0. And f of 1 is going to be 1 squared, which is just 1. And f of 2 is equal to 2 squared, which is equal to 4. You can see that I've got that nice little turn here because I'm decreasing and then I start increasing. So you know you're going to make the turn, which is good. So I'm going to have that U shape. Okay, and once I have my ordered pairs, I just go and plot them on the coordinate plane. Remember, this is my x and this is my y. Okay, x is horizontal, y is vertical. So when x is -2, y is +4. So I go over here to -2, +4, and I plot a point. Do it again for the next one. -1, 1. 0, 0, 1, 1, and 2, 4. plot all of those points. Now, if you need to plot more points, you can, so that you can make sure you see the U. If you want to plot them more so it's more exact, that's fine. And then you just connect the dots. Don't leave it like this, okay, because you're going to be incorrect. Because I chose these particular points. That doesn't mean they're the only points. I could have chosen other points. So make sure you actually connect your little dots. Okay, try to be as neat as possible. Now, I know these things aren't going to be perfect, but you do need to be very careful with them. Take your time, because it does need to be close. Okay, if you're graphing something and you get really sloppy with it, and I don't feel it's close enough, you're going to lose points for that also. So make sure you try to go through your points that you actually plotted when you go to graph these things. Okay, so that would be a quadratic, which if you look back at the parent function chart, it looks just like this. It comes down, it touches 0, 0, and it's got that nice little U shape. Okay, but this is graphing using ordered pairs, and you need to be able to do this. You need to be able to create this chart. Okay, now here's another one for you. Okay, so if I do f of x is equal to the absolute value of x, so I'm going to do the same thing, make a t-chart, x and y. Okay, plug in my values. I'm going to choose -2, -1, 0, 1, and 2 again. Okay, and I'll talk about when you need to change those numbers here in just a second. But right now, let's go ahead and find all those values. So f of -2, absolute value of -2. Remember, absolute value means distance, so we're just going to drop that negative. So absolute value of -2 is just +2. Do that for each one of them. F of -1, absolute value of -1 is 1. F of 0, so absolute value of 0 is just 0. F of 1, absolute value of 1 is equal to 1. F of 2 is equal to the absolute value of 2, which is just 2. Okay, again here, make sure you know your parent functions and what they should look like. I should know that the absolute value has a V shape to it. Okay, so I should see that turn again, only this one's going to be straight lines instead of curved like the quadratic. So I get -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Plot those points. Okay, 0, 0, -1, +1, -2, +2, +1, 1, +2, 2. Okay, so I've got this nice little V. I connect my dots. Should go through like such. Okay, again, it doesn't have to be absolutely perfect, but it does need to be close. And make sure it goes through those points that you just graphed. Okay, so that would be the absolute value. So again, I urge you to hit the pause button. Okay, try to graph this last one. Make sure you're getting the right answers. Make sure your graph matches up. And then we will talk about when to use different x values. So hit pause, see if you can graph this first. Okay, so for instance, when you come back, I'm going to do my t-chart. Okay, I'm going to use the same values again, -2, -1, 0, 1, and 2. And I'm going to plug them in. So f of -2, absolute value of -2 plus 2. Okay, the absolute value of -2 is just 2 plus 2, which is 4. So 4 is going to be my y value. Do that for each and every one. So f of -1, absolute value of -1 plus 2. Okay, the absolute value of -1 is 1 plus 2 is equal to 3. Okay, so I get a 3 there. F of 0, absolute value of 0 plus 2 is going to be 0 plus 2, which is 2. Excuse me. And then f of 1, which is the absolute value of 1 plus 2, which is 1 plus 2, which is just 3. And last one here, f of 2 is equal to the absolute value of 2 plus 2, which is equal to 2 plus 2, which is just 4. Okay, please do note that I've done 5 points for every one of my examples that I've done. Okay, you need at least 5. Okay, at least 5 points, and I believe the test actually says that you have to have at least 5 points. Okay, but sometimes you might have to do more, because again, if I don't see that V shape happening, then I might have to include some more points to make sure I get that nice little V shape for my absolute value. Alright, so plot all those points when x is -2, y is +4. When x is negative 1, y is positive 3, 0, 2, 1, 3, and 2, 4. Okay, and I have that nice little V shape here. Graph those out. Okay, and hopefully here we notice that this graph just shifts up 2 from the previous. Okay, it shifts up 2 units from the previous one. It's the exact same V, it's just shifted up 2. Hold on, my screen froze yet again. There we go. So it shifts up 2 units. Okay, so what you can say is that when I'm adding or subtracting a value to a parent function, because this isn't going to be just for absolute value, it'll do the same thing for quadratic, but if I add or subtract a number to a parent function, then it's going to shift it up or down. Okay, so that's this next one. What do you think you can determine from the previous? This should say 2 problems. Okay, 2 problems was if I add or subtract from a parent function add or subtract from, oh, sorry, you can't read that. If I add or subtract from a parent function, then the graph will shift up or down. So some examples for that would be if I did something like x squared plus 4. Okay, well my quadratic is my parent function, it's just the x squared, which is going to be the nice U shape, and this plus 4 over here means it will shift up 4 units. Okay, same thing as if I had x squared minus 3, this would shift down 3 units. Okay, they'd both have the same shape, just shifted vertically or 4 units or down 3 units. Okay, and we'll talk a lot more about this in transformations, which will be done on block day, and that would be section, I believe it's 8.4. Might be 8.3, 8.3 or 8.4. Okay, so you'll see that transformations, we'll talk a lot more about the shifting vertically, and we'll talk about how you shift things horizontally. Okay, so the last thing I want to say before the end of this video is, I said sometimes you won't use these numbers. Okay, I use these numbers a lot because they're small numbers, they're easy to work with, they're easy to graph, they're all really close to the origin. That's why I always use -2, -1, 0, 1, and 2. And they also typically give me, I've got some negatives and some positives, so I get to see both sides of the graph. Now, I said that sometimes you may have to include more. Okay, so for instance, if I was doing this and I hadn't seen that V shape happen, then I would have to keep adding numbers keep adding new x values until I actually saw the turn where I saw that V. Okay, or something like the square root of x. So let's say I have f of x equal to the square root of x minus 3. Okay, well, I can't just put any number I want to in there. If I put a -2 in here, I'd get -2 minus 3 is -5. Well, I can't take the square root of 5. That's going to give me imaginary numbers. Okay? So when I think about the square root, I want to try to get all of my perfect squares. One of my perfect squares, 0, 1, 4, 9, 16, 25. Any of those numbers would work because those are going to give me the perfect square. So what I want is underneath here to be one of those numbers, 0, 1, 4, 9, 16, and 25. So for instance, if I try to do my x, y, t chart, let's say if I want to get 0 underneath here. Well, I could let x equal 3, okay, because when I do f of 3, I would get the square root of 3 minus 3, which is square root of 0, which is just 0. Okay, square root of 0 is just 0, so I could put 0 there. Now I could do the same thing. Now if I want to get a 1, I could do x is 4. 4 minus 3 would be 1. So f of 4 would be the square root of 4 minus 3, which is the square root of 1, which is just 1. That I can do. Okay, so I'm going to skip all the way up to try to get a 9 in there. Okay, so, or 4, sorry, I want to get a 4 in there. So what would give me 4 underneath here? So if I did 7, so if I did x is 7, then f of 7 would be the square root of 7 minus 3, which is the square root of 4, which is just 2. So y would be 2. So you want to pick x values so that you end up with this perfect square. Because what you don't want to do is say like I said, if I did, I don't know, say I did x is equal to 5. Okay, so I want to do f of 5. Well, I'm going to get the square root of 5 minus 3, which is the square root of 2. Okay, I don't want to try to graph the square root of 2. It's going to be some nasty little decimal. It's not really something I want to have to graph if I don't have to. So instead, I'm going to make nice pretty numbers so that this number right here keeps giving me perfect squares. So like the next one here, I would want a 9 underneath. So to get a 9 underneath, I'd have to go all the way to x is equal to 12. Okay, f of 12 would give me the square root of 12 minus 3, which is going to be the square root of 9, which would be 3. Okay, so y would be 3, but x would be 12. So hopefully that'll help you, because that'll show up on your test, it'll show up in quizzes, it'll show up on your homework. Okay, that would be one of those. You can't just pick every number, because you can't get negatives under square roots. You're going to get imaginaries, and you can't graph imaginaries, at least not on this plane. You can graph them, but not on this plane, so we're not doing those right now. Okay, that's the end of that.